I know what you're thinking. There is no way that this guy can come up with another transformer calculator before this year ends. Well, what can I do? Some time ago I came up with the idea to make a calculator that would calculate the optimum of everything from lamination and bobbin size to wire gauges and stack height and everything else with as little information provided by the user as possible. In the end, I managed to achieve even more than I originally planned. I found a way to calculate all of the things mentioned, and I've made it so easy for you that it looks more like making an order or a wish list than an actual transformer calculation. You just need to type the desired voltages and current ratings for your transformer, and the wizard does the rest for you. To demonstrate it and make sure everybody can use it successfully, I used it to calculate the power transformer for my Pultec EQ clone build. The original Pultec uses Chicago Transformer's PCC55 power transformer, which conveniently shows the voltages and current ratings on the original box. So we start up our Transformer Wizard spreadsheet and make sure we have correct mains or primary voltage there. I'm using the metric version here, but you can use Imperial one, which is included. The voltages from the original box are most likely nominal voltages and not no-load voltages. And to get no-load voltages, the rule of thumb is to add around 7% to the nominal voltages. This is more important for the filament winding because we want the filament voltage to be as close to 6.3 volts as possible after the voltage drop under load. For the B+, it's not as important, and I've used only slightly higher voltage, which resulted in a slightly lower voltage later. But if you want to be precise, just multiply the nominal voltage by 1.07. Anyways, that's 2 times 270 volts at 55 milliamps, 6.3 volts, or 2 times 3.35 volts at 2 amps, and 5 volts at 2 amps for the light bulb. I did not wind the 5 volt winding because it's only used for pilot light, and we'll just use the filament winding for that. After you input all your voltages and current ratings, you go to Step 2 tab. You can see that the wizard found the perfect optimal lamination size, bobbin size, and calculated all the number of turns for each and every winding along with the wire thickness. And it made sure that the combination of all those wire gauges and numbers of turns fits the bobbin perfectly. The Imperial version calculates everything in inches and for Imperial standard dimensions of laminations, and also the wire gauges in AWG standard numbers. Sometimes you might get more possible options or answers. When you go to Step 3 tab, you will have the winding data nicely displayed to make it easier to print and wind from. Note that the winding images are only displayed in mech numbers version, which is included along with the standard Excel version. And believe it or not, in only 3 very simple steps you've calculated your power transformer. As I said, I will not use the 5 volt winding because I don't really need it, so I will go back to step 1 and recalculate the transformer. Now to demonstrate that any noob winder can use this calculated data to wind the transformer and fit the wire to the bobbin, I will wind the transformer on my CNC winder, but I will guide the wire by my hands instead of the CNC wire guide. Out of the 2 options, I've selected the one suggested by the wizard in step 3, which is 28 by 28 millimeters. I had all suggested wire gauges on hand, so I started winding the primary winding. Hand feeding requires a bit of practice, but after a while you will get the feel for the wire tension and all the other tidbits. By the way, if you like what I'm doing, please subscribe to my channel and give a thumbs up for this video. You can also support me by checking out my Patreon page in the link in the description. So I'm using the heat shrink to secure the wire here, and I'm preparing to start winding the primary winding. So it's not really important what I'm setting up here other than the number of turns, because I was not using the CNC winder. I just used my hands to feed the wire, as you can see, and just wanted to make sure that even if you don't do a perfect winding, that it will still you will still have enough space on the bobbin to fit all the wire and not to stress about it. So it turned out perfectly. So you want to keep the wire as tight as you can, but not burn your hands, of course. I'm winding the filament winding by hand fully, so without even using the machine motor. And this way, since it's only 19 or 20 turns, you can do it by hand and just guide it easily. This is also center tapped, so we have two windings, and later we connect the center tap together as one lead. As you can see, all of the windings fit perfectly to the bobbin, and we still have some space left for the 5-volt winding if we would want to add it. And here's the final view of the finished transformer. So it has been fully finished, and you can see we have our filament leads, the green ones with the blue center tap, and we have the red ones for the high voltage, which has orange for the center tap. And on the other side we have our primary, which is the black two black leads. I will test it now to check if it's working and to check the voltages. Of course, this meter is not accurate. It's giving a slightly lower reading than it actually is, but still, even as such, it's we can see that it's working and it's close enough to what we've spec'd it for. The 6.3 filament winding is also in the ballpark, so once under load, it's gonna be okay. I think the B plus might be slightly lower than what we would get nominally with the original, but I guess with the higher values of modern caps in the power supply, it's not really a big deal. So this is it. We can see that the calculator works perfectly, and it is a really great way for someone who is really afraid of all the magnetic flux density and all the other lamination specs and everything that might turn you off from winding your own transformers. This is really a great way to calculate your transformers and to start, and then after that you can learn more and understand more, and then tweak all the details to get the even better results. Thanks for watching.